Welcome to Python for Introductory Statistics. In this video, you will learn how to do a chi-square test of goodness of test. Let's look at this example. A store manager claims that a plain M&M bag of candies contains an equal number of each of the six colors: brown, yellow, red, blue, orange, and green. The counts for each color of a randomly selected bag of plain M&M is given below. So these are called the observed frequencies. So from the bag that was randomly selected, there were 57 brown, 64 yellow, 54 red, 75 blue, 86 orange, and 64 green. So now in order to do goodness of fit, first let's call these frequencies, they're called observed frequencies. So we'll use OBS and we will put them as a list in Python. In this case, we'll use Google Colab. So let's add a new code here. And we're going to need to import stats from stats comes from SciPy. So from SciPy, import stats, and then let's list it. So the observed values are given. Now, the expected values are under the null hypothesis. If the store's claim is correct, then we should have equal number of M&M candies for each color. So we have to add this and divide it by the six colors here, right? So let's use Python to do the sum. So let's call this sum. It doesn't matter. We call it sum1 is equal to observe and then sum. So this all we'll do is we'll just want the sum of the observed values, and then we'll divide it by 6. That's how we'll know. All right. So let's see. Here it is. So the sum1 is now adding. Now we needed to add one more code. We don't need to see it, but we could have seen it. So now each of the observed values would have been observed values. Actually, let's print sum1 so we can see how much was the sum. Now we had to divide. They're exactly 400 candy. So we need to divide this by 6 to make the expected frequencies. So this is the observed frequencies. Then the expected frequencies will be on a list. So this would be 400 divided by 6, but there's 6 of them. So we will just take all of them and divide it by 6, and that would be the case if the null hypothesis is true. So let me do it right here. Now we have both observed and expected. Now we're going to call the function from stats. So it's called stats chi-square. Oh, there it is. Chi-squared. And we'll put observed first, right? OBS, and then expected, which is exp. So these are the two data. When we run this using this function, so you have to remember this is crucial, stats.chi-squared, it tells us that the test statistic is 10.67 and the p-value is 0.05. So at 5%, there's not enough evidence that they were equally distributed or uniformly distributed. So this is what you need in order to do the chi-square test of goodness of fit. Does it fit? Does the distribution of candies were uniform? And in this case, the test says they were not, or there wasn't enough evidence to support that claim.